This lesson from Friday was when we were talking, we did a few things. One, we reviewed a bunch of exponent rules, right? When you multiply bases, you add the exponents. When you divide bases, you subtract them. We talked about when you have a power raised to a power and all those things. Then how we used those was we rewrote so that both sides of an equation had the same base. We would use the rules to condense bases. Remember we had that one long problem with all the e's in it at the end of the day? And we were trying to figure out where we could apply which exponent rule to condense the bases down. So like, for example, on the left-hand side, there are two base 4s here, right? And they're being multiplied together. Our goal is to get one base on the left and one base on the right, because when we do that, like if we had this, once the bases are the same, you can set the exponents equal and do more math or solve or whatever. But we can't do that yet on the left because there's two bases. So we have to figure out which exponent rule applies here on the left-hand side. Any ideas? Which exponent rule we can use on the left to condense those two 4s into one 4? Adding the exponents. We can do that because what are we doing with the bases currently? What operation? Multiplication. So when you're multiplying two things, so this is what the general rule was from your notes. The general form. What is in the place of A in our specific example?
1.
In the place of the A? 4. What's in place of the M? A 1. And so to rewrite this, we keep one base and we add the exponents. And we don't have to do anything to the right because it's already in terms of one base. There's not multiple bases going on. So now that each side is in terms of one base, we can take the exponents and set them equal. I hear sometimes students will say we can divide off the 4s. That's not actually what we're doing. We're not really doing any math to the 4s at all. We're just now talking about the exponents only.
You know, add from 1 to 6.
Before you write that step, you can. You absolutely can. So now take a minute and solve that equation and see what you come up with. Absolutely. So we got x minus 5 equals 2x plus 3. This is a two-step equation. Negative 8 equals x. My 6th grader is currently doing two-step equations at school. And just tell you why we're learning it. And you don't have to write this down. I just want to set it up for you, like why we even care about this skill. Friday we talked about how you could solve equations like this, where the variable is in the exponent position, but the bases are the same. Once the bases are the same, you just take the exponents and you set them equal to each other. There's no more math we could do, but if we had to, we would just solve it. Then we talked about, well, what if the bases weren't written the same, but you could get them that way? Like you could just rewrite it so they have the same base. You would say 16 is 2 to the 4, and then now you would say 4 equals x. But what we're learning today is for situations where you cannot rewrite the thing on the left to have an integer exponent right there. So for example, if I had 9 equals 2 to the x, and I was trying to rewrite the left side as 2 to some number, there's no number, right? At least no integer number that would work right there. So what we're going to do today is learn a way of solving this problem. And it's just by converting from, so this is called exponential position, I just made that up. The exponential form, we're going to rewrite it in log form, and here's why. They are inverses of each other. We always are using inverses when we're solving equations. You know, if we had Instead of 9 equals 2 to the x, if we had 9 equals 2 times x, this is times, what would you do to both sides to solve? Which operation? You divide. You would divide because division is the inverse of multiplication, and they cancel each other out. This is an exponent. The inverse of exponent is log. And so we would apply the log to both sides. Technically, it looks like this. We'd say log base 9 equals log base 2 to the x. We would bring that x forward. Never mind, I don't want to show you that. I thought that would be a good thing to show you, but no, I'm just going to confuse you. Just never mind that. Strike that from the record. We're going to do that later in the unit, sorry. I was like, I'm going to enlighten them, and then I didn't like it. So we're saving it for later. That's why we're learning what we're learning, to solve equations like this. We won't be actually solving equations today. We're just practicing the rewriting skill. So going back to this section with all the words, this is the basic form we're talking about, okay? Log base a of x. This is how you read it. F of x equals the log base a of x. There's the words in case you didn't remember how to say it or read it to yourself in your head, like data and data. This part says this is the inverse of the exponential function, which I already talked about. We're going to talk more about that tomorrow when we graph these functions. And then this down here is the two different ways you could represent the same information. This is the log way of representing it. This is the exponential way of representing it. And I feel very strongly about you adding this thing I'm about to write to your notes. This is what I want you to put on here. That arrow going back and forth to remind yourself those are equivalent kinds of information in just two different forms. And then you could decorate it if you wanted to decorate. So cute. All right. So here, I'm going to show you, I'm going to call it the lasso. Right here, your notes call it the log loop. I'm going to call it the lasso. You know what a lasso is, right? The rope with the circle on the end, and you're from Texas, right? And you get the steer in 8 seconds or whatever, and you hold your hand up and you win at the rodeo. Also, Wonder Woman has a lasso, so even if you're not from Texas, you haven't been to the rodeo, you've seen a lasso. You've probably seen a lasso. So the reason why it's called the lasso, it'll look like a lasso after I draw it. Here's what I want you to do. Put your pencils down and watch me do this lasso, right? You always start at the base. What's the base here? A. You start at the base. You loop around to the opposite side of the equation, and you encounter B. That's your exponent. And then whatever is in this position when you get back to the beginning is what you put on this side. So this was log form, and this is how you rewrite it in exponential form. And I'm going to show that to you again, but I do want you to write the steps down. Here are the steps, and you can use whatever shorthand you want. The first step is to start with the base. You begin there every time. The second step is to loop away to the opposite side of the equation. And then the last step is you end where you began on that same side. So watch one more time with your eyes up here. I'm going to do that again for the log. I started at the base. I looped away to the opposite side of the equation. So that gives me, so I started with the base A. Looping away, I get to the B first. B is my exponent now. I end where I began, so that equals x. And we're going to do that same thing with this version over here. This form, a to the b equals x, what's that form? Is that exponential or logarithmic? Exponential. So if it's in exponential, I'm rewriting to what form? Log. So I need to just go ahead and put log down so I don't forget that that needs to be written. And step one, start with the base. What's the base here? A. If I'm looping away to the opposite side, am I going to go to the right or to the left? I'm on the left side. What's the opposite? Right. So I loop around this way. So I've got log base A of x equals d, wherever you ended up. One thing I want you to be sure is this on the log form. Your base, wherever that base, whatever your base is a subscript. It does not get written on the same level as your log, the LOG letters. Subscript means it's slightly below. But the x, whenever you put this thing here, is equal with the log. Log, x, and b are all on the same line. And a is just a little bit lower. And that just helps, you know, if you were ever to if someone else was reading your handwriting or whatever, they would know what you meant for the base and what you meant for the other things. Questions about anything on here? We're going to do some examples. This whole first screen, everything is in what form right now? Log. So I'm going to do one. What time do we get out of here? This is 7th period, 3:25. Thank you. We have 20 minutes. Okay. So looking at the first example, if it's in log, that means I have to rewrite it into what form? Did I ask this already just now? It's in log, so we're going to exponential. Fabulous. So we're starting with the base. What's the base in the first example? 4. So that's on the left. We have to loop around to the opposite side. I keep repeating that because if this was switched, you would have to loop to the left side. So it's base 4 to the 3 equals 64. And by the way, you don't even have to do the lasso. You can just remember how to switch the forms. This is just like a shortcut to help you out. And is it true that 4 cubed is 64? 4 times 4 times 4, 64? That's true. You do those two, please, and I'm going to randomly have someone come up and do one, and then they can pass the pen on to somebody else to do it. So take a moment. These make sense because 81 to the 1/2, remember that's a square root. What is the square root of 81? 9. And then here, 10 to the -3 makes sense because you flip it, you make the exponent positive. That's 1 divided by 1,000, which is 0.001, right? So here we went from log to exponential. Now we are going from exponential to log. I'll do the first one for you and then have a couple of you youngins come up and do the other two. You're youngins. What's the base here in this first problem? What's the base? 2. So we're starting at the base. We're looping around to the other side and ending where we began. But then I get confused because I'm like, I want to write it like this, but that doesn't make sense because I'm still in exponential. And so then I get confused. It's log form that I'm going to. So then I have to say, oh yeah, okay, I need those letters that spell log. So that's how I know where to start. Thank you for clarifying for me. So log base 2 of 1/16 equals, what? Equals -4. I never know what to do when this happens. Log 2 of 1/16 equals -4. Log and 1/16 and -4 are all centered. Their centers are centered, and then the 2 is a subscript. All right. So do those two, and then I'll have a couple of you come up, and then we'll do our Kahoot. There is one thing I want to point out about when you're writing logs. It feels kind of like this part right here is an exponent, but it's really just, you're just writing it in line with log and 1. Like, you don't have to put it in the air. And it's not that it makes it wrong, I just sort of want to be picky about it, especially in case you ever have to write anything, like when you go off to school next year, you have to enter it, I don't know, into a computer thing, or just so that you know exactly what the correct alignment is. That's really not that big of a deal. So you have that, you have your homework.